Welcome everyone. Over the next, that's the official talk of the title. I didn't bother to write that on the piece of paper. But welcome everyone. I would like to give you over the next 30 minutes, as I said, a brief introduction of web security and things that I believe are important for every web developer, no matter whether you're responsible for security or not, because in my opinion, everyone is responsible for security, and not just the person who has it in their title. And hopefully by the end of the talk, all of these abbreviations going to make a little bit more sense to you. But before we start, I would like to introduce myself. So I'm Dominik. I live in Berlin and I work as a developer evangelist for a company called Twilio. We were the ones who put out the t-shirts if you managed to grab one. And we're an API company that has APIs around communications such as SMS, voice, video, or chat, as well as things like two-factor authentication. But there's one more thing that you should know about me, and you might have gotten a hint by me running around like this. I'm part of a group called JWTS. We're just a bunch of lovely people that you're more than welcome to come up to and chat with us. That's us at the first time we kind of pulled this off back at Road.js, which is an amazing conference organized by Madeleine, walking over there. And now running away. It's a social network for web developers or developers in general who love onesies. And being a developer, I obviously made sure that this is as secure as possible so that people with bananas can't hack it. If you see the banana trying to hack there. And I thought of everything. So it uses HTTPS, and thanks to Let's Encrypt, there's really no excuse to not using HTTPS because you can do it for free. It uses HSTS, which is the HTTP strict transport protocol, which is a thing that make sure that you can't go to Google when you're on an open network that is trying to redirect you to a captive portal. Basically what it makes sure is that there's no downgrade in your connection when you from HTTPS to HTTP. I'm making sure that there's no mixed content, meaning there's no HTTP content on my HTTPS website. I'm sanitizing the input because it's a social network, so obviously you can post things, in my case with Markdown, and I'm sanitizing that input. And there's no room for SQL injections because if you are not using a real database, there are no real SQL injections. And I'm not talking about NoSQL databases because there are NoSQL injections as well, but I'm really just using a plain storage, so there's no room for me to have any SQL injections or NoSQL injections. Turns out though that developing secure web applications isn't as easy as I thought. So I asked my buddy Bob Allison to kind of take a stab at the application, and they found a bunch of vulnerabilities that I wanted to share with you. And with that, let's actually take a look at the site. Now you can actually see it. So this is how the fluffiest social network in the world looks like. I'm gonna switch to cloning so I can. All right, so if we go here, that's the login portal, and I'm gonna open the DevTools here. And go to the network tab just so we can see what's actually happening on the side. And I'm gonna log in here with my super secure password. And what we're doing is we're doing a normal post request, and we're signing a auth token here, which is what is called a JWT, a JWT or a JSON Web Token. And if I go to I've installed a small helper tool here to let me work better with the tokens. But if you never saw how a JSON Web Token looked like, there's a nice tool called JWT.io where we can inspect this. And basically, a JSON Web Token has 3 different sections. So it has a header which defines, hey, this is actually a JWT, and then it has an algorithm which is used to generate a signature, which is the last part of it. And then in the middle we have a payload, and this payload you can have arbitrary data. Now the header and the payload, you should be aware, are not encrypted. They're simply base64 encoded, so you should never have sensible data in there anyways. There shouldn't be a password in there. Please don't put a password in there. But to make sure that this can't be tampered with, we actually have a signature. In our case, we can see the signature right now is invalid because I'm trying to verify it against a secret called secret, and I was smart enough to not use that as my secret. Now the thing is, if you look at the spec of JWTs, there's a bunch of algorithms that this should support, and one of them is called none, which, as you can see, the signature disappears because we're just simply not generating a signature. And this is sort of meant to be for, like non-sensitive data if you just want to transmit data in like a standardized format. The thing though is that we can try and see if my library is weak enough to fail with this. So we switch the role to admin and just submit this. And if we refresh the page now, let's see if you notice any changes. We're now able to authenticate as an admin. In fact, we wouldn't have had to log in the first place. We could have just generated this token because I'm verifying this token and then take that as a source of truth on my website, which is what most websites actually do. And that's, as you can see, not great because we could log in as any user. So how can we protect ourselves from that? The first thing you should do is you should really use HttpOnly cookies if there's no reason for it to be accessible in JavaScript. And in this case, the authentication token, there is really no use for it to be accessible in JavaScript. You should also make sure that it's signed, meaning it's signed with a secret so that nobody else can tamper with it. And it's secure, meaning it's only transferred via a secure connection. But then there's also the fact that you should use a secure JWT implementation. So the library that I was actually using is JSON Web Token, but I was using an old version of it, and the old version has two drawbacks. It doesn't allow you to whitelist algorithms, meaning specifying only the algorithms that should be supported. In this case, I really just want to support HS256. And then good implementations also have this fallback where if you're trying to verify a JWT that has no signature and you're trying to verify it with a secret, then this should fail. Like if the secret isn't null, this should always fail. So if you're up to date with your dependencies here, you'll be able to kind of not be the next Equifax and instead have like a secure implementation. If you're not familiar with the Equifax story, you should look that up. But basically, that was a massive hack that happened in the US. Purely because the company wasn't up to date with their software, and there was a known vulnerability around this. Cool. So I said this is a social network, so obviously, let me fix this because it's getting really warm under this. So obviously, you're able to post things on this. So if we go back here, I said this is Markdown, so we can do things like hello JSUnconf, how are you? And we can post this. All this does is, again, it does an HTTP post request here with some form data in the bottom with the actual message. And then we use the auth token to verify that, like, on which user's behalf we should post this. Now, the problem with that is that this can be used by attackers to perform so-called cross-site request forgery. Since we're using cookies, the browser is sort of overly eager to see, hey, I have cookies for this page, so I'll just submit them. I'll just send them with every form request, even if they're on a different domain. So that basically an attacker can impersonate you by just kind of getting you to, if you're logged in on a page already, to go to a website and then they can do things on your behalf. So the first thing that happened was when I went to this page, this is a target blank link, so just a normal link that should open in a new window. The problem with target blank links is that the new page has access to the opening page by using window.opener. And window.opener has a location property, and that works just like the location property that you would use on your normal window, meaning you can redirect page requests, you can redirect the original page to anything else. And that's what an attacker could use then. In our case, we just navigated it to like a harmless page, but this could be a phishing page as well, and users would likely not detect that. So in the case of something like Facebook, if you would post a link there and they would use target blank links, the new page could then do window.opener and kind of redirect you to something that looks like Facebook, and most users would not detect this unless they see it in the URL bar. Fortunately, there's a way to protect yourself against that. There's actually, yeah, I should reboot. There's two properties that you should add under the rel attribute, which is no opener and no refer. So no opener makes sure in most browsers to just not give the new page access to window.opener. And then no refer will make sure that on the browsers that don't support no opener, that you will actually not have access to the refer link. to protect yourself from cross-site request forgeries or CSRF attacks, this is fairly straightforward as well. It's a bit more work because what we need to do is when we get the page that you want to do the submission later on, we need to generate a CSRF token. So that's just a unique token for the user that we will set on the one hand as a cookie, in our case _CSRF, and then we will also submit that on the page somewhere as, for example, a hidden input field. And then when we do the actual post request, instead of just submitting the cookie, we will also manually submit this value either as a header or we will submit it as a request body or query parameter. And the reason why this actually protects you from these sort of attacks is that the attacker would be able to kind of leverage the fact that the browser sends these cookies automatically, but there's no way for the user the attacker to read the cookie because it's blocked by only being accessible from your own domain. So that's why this protection works. Now let's talk about Little Bobby Table's younger brother, the cross-site scripting attack. If you're not familiar with Little Bobby Tables, it originates from an XKCD comic where a family of hackers named their kid like a SQL injection, and the director of the school is sort of mad because it dropped all the student records because they weren't sanitizing their inputs. And if we talk about cross-site scripting, this is one of the most famous cross-site scripting attacks. Does anyone have an idea what this source code is from? So far, I haven't seen anyone who guessed this. All right, so this is from a famous attack called the MySpace worm or Sammy worm or JS Space Hero worm, and that was a cross-site scripting attack from 2005 performed by a person called Sammy. And what this would do is he posted this on his page, and it would send friend requests to everyone who visited his page and then post that on their page and then send friend requests to them. That's also how they caught him, because Sammy had overnight several million friends on MySpace, which is a slight indicator that he did something. And the reason why this is interesting is that MySpace actually had XSS protection, but Sammy was able to circumvent this XSS protection. And two of the tricks that I personally found interesting were these two. So there wasn't any possibility to use inline script tags, so Sammy couldn't use that. However, what they allowed was to use CSS. So he created a div tag and used CSS and specified the background URL to then have a JavaScript protocol in there that let him write JavaScript. They disabled, though, to use quotes in there. So what he had to do is he had to basically eval another attribute that he would pick out of the DOM. In this case, it was just the same div tag, and then eval that code where he could write the code. The other thing is they blocked certain keywords, such as inner HTML or on-ready state change, which is used on AJAX requests if you're not using something like jQuery or if you're not using something like fetch these days, which wasn't around at that time. However, he circumvented that by basically turning those words into strings, chopping them in the middle, reconcatenating them, and then evaling that, because no regular expression was able to catch that. And he used a bunch of other tricks as well. If you want to read about them, you should check out that blog post. But the bottom line here is that it's really hard sort of to block XSS. And now you might say, well, I could just block eval, right? But JavaScript is this beautiful language that allows you to write JavaScript code in a million ways. So all of these do eval. And those are not the only 4 solutions. Like, we can do way more. Martin Kleppe, he's actually from Hamburg. He did a great talk at JSUnconf Iceland about how he wrote JavaScript in Hebrew and in sort of all sorts of other languages, including languages from the Star Wars universe. Sort of like, you can write this in any kind of character set. So you should really just not trust that you can just block things by regular expression. So bottom line is, blocking XSS is not trivial, and in fact, I have a vulnerability on here as well. So if we go here, the library that I'm using to convert the markdown to HTML is called Marked. It's one of the most popular libraries on NPM to do that, and the version that I'm using is not the latest, but the second to latest or something, and that one actually has a vulnerability. So by default, it has a sanitize function, so things like alert hello won't work, but let's just be sure. So this doesn't work, it's being escaped. Now we can use a similar trick to SAMIs and use the JavaScript protocol here, and we're just going to create a link here. So that's how you create a link in Markdown. And we're going to try to do alert 1 here. I'm going to copy this. And this is being escaped as well because the library is smart enough to detect that that's essentially just writing inline JavaScript. Now this is where it becomes fun. I'm just going to make this a bit bigger. I'm not sure how familiar you are with character encodings, but you can express a closing parenthesis as #41 semicolon. That's literally the same character. And if you look up your ASCII table, colon is #58 semicolon. And if we post this, we'll see that's already a difference, right? There's no closing parenthesis here anymore. There's just no text, so we're getting somewhere. But it's still smart enough to figure out that, like, hey, #58, that's a colon, so I'm just going to block this. However, if we add this small word, this, the best word in JavaScript, because we never know what it is, the story looks a bit different because suddenly the link appeared. And what happens here, and if we click at this, we'll see that it actually works. The reason why this works is that the browser tries to be helpful. And the browser sees, oh yeah, you're using #58. I don't see a semicolon, but I think that's just a typo, so I'll just insert that for you. And then everything afterwards turns valid JavaScript. So that's why I use this in this case, because it's a valid JavaScript. If I would write some other things, it would fail and wouldn't execute the next line. But because it's valid JavaScript, this just works. Shout out to Guy from Sneak who actually showed this to me. They were also the ones who fixed this in this library. Unfortunately, there's still a vulnerability in this library around data URIs, but it's a bit harder to demonstrate. So I decided to show this one. But the bottom line here is really that encoding can be really dangerous, and there are a million ways to express the same code. So just never trust user input. Be as skeptical as you can. Also, don't trust CSS, because CSS can be dangerous as well. Jake Archibald recently published a nice blog post about this, kind of showing how you should just not trust third-party CSS, because there are a bunch of things you can do about this as well. That's just a talk by itself. All right, let's talk about JSONP. So JSONP, if you're not familiar with that, has especially been used in the past to circumvent same origin policy. So that's the idea of loading data asynchronously on your page from a separate domain. And that's by default blocked with AJAX requests, but there's a way to kind of like circumvent that. And the idea there is you create a global function and then you insert dynamically a script tag. In our case, we just placed it in there. And this is a JSONP-enabled endpoint, meaning it gets some query parameter with a callback name. And what it will do is instead of returning the plain JSON, it will wrap the JSON into a function call so that basically this is being triggered as a callback function. Now, this by itself is harmless unless you crappily implement it. And that means that you're not verifying what you're passing in here as a callback. And if we have that and we have a cross-site scripting vulnerability, this is where the fun part starts. So for whatever reason, I was logged out again. So let's just log in again. So how many of you are familiar with service workers? All right, so if you're not familiar with service workers, they're a network proxy that you can install, meaning it can intercept network requests and sort of is often being used to create offline available apps, so you can cache things manually and you can control the cache. Now, this is a very powerful feature, and that's why the browsers only allow you to install it from your own domain. So that an attacker can't install one. Now, if you have a JSONP implementation that is vulnerable, meaning it doesn't verify what you're passing in as a callback, you have a page on your own domain that allows you to generate any JavaScript. And that's what I'm doing here. So if I install this, if I post this, and we click this link, we will see first nothing, but then I refresh the page. And I can refresh this as often as possible, but I'm only seeing this hacked. Because what happened, and actually that's where I need the dev tools, but let's see if we can, oh, they're working again. I have no clue what's happening here. So we can see that it installed a service worker, and we can see that this is a very long URL for a service worker, because what I'm doing is in the callback, I'm specifying the entire source code of this service worker. So we click here, that's the entire code. Basically, it's a bunch of code ending with a / to kind of comment out the entire code, mainly because we don't care about it, like the entire payload. But we could also just keep that going. Now in here, all we do is we say that, like, hey, any request that isn't to port 4000, we just override it with an H1 hacked and some other code. Now this is a very obvious one to pull off with this. What you would typically see an attacker do in this situation would be to insert a script tag secretly without you ever noticing it. Because they don't have to override the entire request. Response, they can just insert something and then keep it going. So you would never notice this. Like, if this is installed, it's really hard to detect unless someone actually reads the source code of the service worker they have installed, which at least I don't do for other websites. I'm not sure if that's something you do as a hobby. But if we unregister this and refresh the page, it works again, except that, like, you don't see it, so I'm going to close that. There we go. There we go. So now the page works again. Cool. So luckily, for a lot of these vulnerabilities, there's a sort of hero in town that can protect you called Content Security Policy. And what this does is it allows you to specify a set of rules that the browser should play by with respect to your resources. So if we go to this page, the only difference it does is it applies CSP on this. So the first thing we see is that down here, there used to be images, but they disappeared. And if we click here, that doesn't work anymore, and this doesn't work either. So if we look here and we go into the console pane, we see a bunch of red messages, and all of them kind of go in the same direction of saying, hey, all of these violate the content security policy, or CSP. So how does this look like? It's essentially just an HTTP header that defines these rules to play by. So in my case, the CSP says, hey, the default source that we allow is anything from my own domain. However, for scripts and styles, I only want to allow things that use a certain nonce. So that's something that changes on every request, so attackers can't hard code this, meaning only things that you on request are convinced that should be there can be there. I completely block objects because I don't see any use case for Flash on my page. In fact, I don't see a use case for Flash on any page, but feel free to convince me of other things. For images, I only allow things that are hosted on my own domain or from api.adorable.io, which I use for these adorable icons here. Some of them are adorable, some of them are sort of weird. And that's why, for example, the Twitter images didn't work that were further down on the page. I block all fonts that are not on my own domain or on Google Fonts, and I block all mixed content, meaning no HTTP content on the page, as well as a report URI, which is where it would report any kind of like failed request. So if we go to my terminal, we can see all these requests being made here, kind of like giving you information about, hey, what was violated. There's a way to run this in report-only mode as well. So if you're trying to gradually move over to that, you can say that, like, hey, just report, don't actually block the resources, which is a good way to kind of like detect during development and stuff like that. Like, hey, what are actually things that are being blocked by this, and are we destroying the functionality of something? CSP though shouldn't be your like security policy. Like, you shouldn't just rely on that and be like, oh, nothing can happen to me now. It should just be a safety net, because writing really good CSP is hard. So if you're relying on that, there was a paper of Google where they kind of looked at CSP policies on famous websites, and a lot of them were completely insufficient. So you shouldn't rely on that as a security policy. Always kind of think of all the other vulnerabilities I showed you and try to fix them. Just have this as a safety net that in case you screwed up something or a dependency screwed up something, that you're a bit safer. Other things you should look out for are things like clickjacking, meaning you shouldn't allow to iframe your page unless you really have a use case for that, and most pages don't. So you can use that do that via an HTTP header that can either be deny or self. Self would allow you still to do it on your own page. Deny would just completely block it. You should check out libraries like Helmet, which is a library for Express that sets certain HTTP headers on your requests that are just good practices for security. One of them is disallowing the iframing. Don't show versions of front-end libraries and your server. That's really important because that's like helping the attackers to like know exactly what they need to do, because if they know you're using React version 16.0.2, then they know, all right, those are the vulnerabilities I should go for. And same goes for the server. If they know you're using an Express server, they already know that like those are the things I want to try. And check for types of input. So if you're expecting, for example, a query parameter to be a string, check that it's really a string, because some libraries try to be nice to you and parse things as objects if they see that's a JSON, for example, or as numbers. And especially with objects, this can be really dangerous, because if you're trying to do like a NoSQL database lookup, for example, in MongoDB for like the password being a string, and I pass in an object, I can do a NoSQL injection and kind of log in as any user through that. Other things, consider security audits. Security is hard, so contact someone who is a security expert. If you have someone on your team, that's great. If you don't, hire someone externally, because it's a good investment. You don't want to be thinking about this only when you got hacked, because at that point it gets really expensive. Stay up to date with versions, because their dependencies can introduce a bunch of vulnerabilities that you just never think of. Greenkeeper is a great tool for that, and use tools to detect security vulnerabilities in your dependencies. So NSP or Sneak are great for that. Sneak, in fact, even patches security vulnerabilities for you, like the data URI one in marked is actually patched if you use Sneak, even though it's not patched in the actual library. To wrap this up, use HttpOnly cookies if there's no reason for them to be available in JavaScript. Be skeptical of JWTS. Just don't treat them as a single source of truth, and have like an up-to-date library. Use no opener and no refer on your target blank links. Use CSRF tokens whenever you kind of rely on like cookies, for example, as an authentication method. Blocking XSS isn't trivial, because encoding can be really dangerous. So just don't think you got that covered. Always be skeptical and try to do different things to kind of circumvent that. Be careful of JSONP. A callback should never contain anything that isn't a word character. In theory, never even like a number, because you could start encoding things. So just have only word characters in there. Use CSB as a safety net, because it's really helpful. And most importantly, stay up to date, because if your dependencies have vulnerabilities, you can have the most secure code on your side, you will still be vulnerable. I'll publish the slides after this talk on this URL, and I'll tweet about it as well, so you can take a look. The entire application that I showed you, including documentation and resources to security matters, on this URL. Again, I'm going to tweet this. And I have stickers, both of these, so if you find me later, I can give you some of those if you're sticker obsessed like I am. And with that, thank you everyone for your attention. I'll be around for the rest of the day if you have any questions.